Hey everyone, my name is VB Malik. So I'm going to talk about some of the opportunities and the challenges that we do have of the generative AI. We have been using it. We have been playing around with the technology itself. Um, I live in St. Louis, and I made a weekend out of this. So I was up in Rockies and Colorado Springs, and again, it's always beautiful to be here in the Denver region. So let's get started. Just a quick agenda on what we are going to talk about. I'll just, introduce. I mean, it's probably, we are, talk about some of the things that have been happening in the generative AI space, but I'll talk about some of the dark stuff happening as well. How hackers have been, leveraging a lot of these tools and technologies itself. Talk about some of the risk overall in this space itself, but then I'll also talk about some of the opportunities on how companies have been adopting to leverage a lot of these technologies itself. Talk about some of the future outlook and the key takeaways at the end, and followed with the Q&A session at the end. So let's talk about this, right? AI is everywhere. Wherever we want to talk about, whether that be in the security space itself or whether you are trying to adopt a lot of these applications into it. But it is a newer attack surface that we know of, right? We talk about a lot of these phishing campaigns that are now happening with leveraging a lot of the AI-based tooling itself. Even in the social engineering space itself, a lot of the AI-based tooling is, whether, a lot of these, tools are now being even adopted into a lot of these social media platforms itself, taking a lot of the deep fakes, whether that be voice spoofing itself, or even leveraging a lot of these AI tools to leverage a lot of these botnet attacks that happen as well. But here's the funny thing, right? How we know of what AI is and how AI is being portrayed out there as well into the world itself. Um, but when you take a look at the entire AI realm itself, we have to understand that this is not a monolith, right? It's a combination of a lot of these tooling itself. Now, depending upon which part of the AI segment that you are thinking about, it could be based upon a lot of the labeling data or a lot of the unlabeled data, whether that be using a supervised learning or whether that be using unsupervised learning itself. Now, a lot of these tooling, when you have the ability to go and create a lot of these things, that's where the generative AI parts comes in itself. And we have also seen that in the past, where there is a lot of these AI-based tooling that basically takes a lot of that data and reinforces based upon the applications that it builds upon itself. And that's where the concept of reinforcement learning comes in. And that's where, depending upon the use case that you do have, you'll often see that a lot of this tooling is being leveraged into the security realms as well to build a lot of these tooling and a lot of these attacks that also happen as well, using one of these technologies to build upon it. Now, when you look at specifically in terms of the generative AI, there are different kind of models, different kind of algorithms based upon that. Some of these that I know and we know of is that there is somebody where we can go and take a lot of these text-based data itself and go and create a lot of images based upon that. That's where the diffusion models comes in, like stability AI and all of these, right? But then there are algorithms which can also go and create a lot of the deepfakes, for example, right? And often we know that a lot of these AI-based tooling also have the ability to take a large set of data to build large language models itself. And then there's text to speech, which is also being able to leverage a lot of the voice phishing attacks that can happen as well, where you take the text and can create a lot of these speech-based attacks and go and create a lot of the phishing campaigns and things like that. Now, when you take a look at the large language models itself, when you start thinking in terms of the constituency of where it comes from, we know that usually when we say AI itself, it comes from that machine learning, deep learning, and ultimately, generative AI and large language models is kind of the subset of how that particular model is being trained upon. So let's talk about the AI attack surface. Now, we know that there is multitude of these data being exposed. There are many, many cases of a lot of these companies, where a lot of that sensitive code data, we had one of those presentations where we were talking about how a lot of that data can go and leak out depending upon you take that data and paste it into, for example, one of your AI GPT applications itself, and basically, can go and leak out. And these are some of the news that we have seen from the very last few years itself, where a lot of these attacks and campaigns have happened. Now, when you take a look at a lot of these attacks and the thing, you'll often see that just putting out those pictures itself, the algorithms are so sharp that they can go and take a look at the pictures itself and can go and decipher a lot of the data that comes out of it. There are many, many malicious Gen AI tools that are built upon it, right? Worm GPT is one of them that, out of a lot of these tooling that are available, all you need to do is just go out there, ask, for example, hey, write me a Python malware script itself. And basically, it will go and give you that particular script itself, which you can go and put it out there into any of those applications and go and attack that. Then there are toolings which are basically, which can go and basically, give you that Python script to go and create a malware script for you itself. And literally you can take that and just copy and paste into any of the, applications that you do have. Then there are now for a lot of the spammers itself, where you don't even have to really go and invest a lot of the time and effort itself, where you can literally go in there and just ask for a spam text itself. For example, if you have, for example, you are trying to, for example, have a working code for let's just say a big banking scam page itself, you can just go and ask for that and it will automatically give you that. So there are definitely now these tools available which have the ability to go and basically, take a lot of that things that we had to literally strive for, to understand that as well. And now you can, that's the ability itself. This is also one of the pages itself. You can literally go and, for example, paste that, and you can try it asking the GPT application itself, hey, can you give me a working code to generate just one of these landing pages itself? And it will automatically give you that particular script to give you that kind of a landing page that you can literally go and build it for your the application that you're trying to beat. Now, another one is the example over here is now, for example, there are these tooling available itself where you can go and, for example, if you want to say, hey, you have a captcha application itself, you want to go and beat that application, you just put over there and it will automatically give you the entire code base itself to go and decipher that particular data itself. Now, when you look at a lot of these applications that are there itself, there are many, many vulnerabilities from the large language model applications itself. From the OWASP top 10 vulnerabilities itself, these are some of the top ones that are out there itself. Whether, we know that, there are many, many large language vulnerabilities itself that we have in the application security lifecycle. But similarly, in the case of the large language model application building itself, a lot of these OWASP top 10 vulnerabilities itself are very much similar if you think about it, right? Whether that be the denial of service attacks that can happen for a lot of the large language models, or there can be a lot of the prompt injection attacks. These can be your typical cross-site scripting, cross-site request forgery itself. The problem with a lot of these large language models also becomes is that a lot of the sensitive data and information can be disclosed and leaked out as well based upon the large language model application that you are building upon. As we go into few of the slides itself, I'll talk about few of the ones which will talk about some of these large language model application vulnerabilities that happen in the space. But before I do that, let's talk about the large language development in application itself. Like, how does it happen behind the scenes? So think about this is a multitude of these steps itself. In the first step, this is where the pre-training data happens, right? Where a large language model has the ability to read huge amounts of data, where it can go and learn the connections between different words and the different phrases. And that's where that takes the information from a lot of the data that get combined from either a lot of proprietary data, or that can also happen through a lot of the public web data that is out available itself. Now, once that pre-training data set is done, then it moves on to the next stage, which is the fine-tuning. This is where the large language model is tuned by human experts for tasks across a domain. And that's also, we also go and take a look at things like retrieval augmented generation itself, if you have a lot of the proprietary data available itself. Now, think of this from the user standpoint itself. If a user goes and prompts and uses a natural language query to go and understand, if it needs something, that's where the prompt engineering comes in, which is the step 4, where you are trying to supplement the prompt to guide the output that is needed itself. And ultimately, you will see that from that, the ability of that large language model to decipher a lot of that data, you'll often see that the large language model generates that output based upon the prompt itself. And that's where the model output. But here, you'll see two big things over here, right? The number one is the input that goes in to the large language model. And that's where we need a lot of the input validation to check the data that is being fed into large language model. And a lot of you'll see is the model output. And that is another one that we need to understand how that data is coming out of the large language model. What are the things that we can do to make sure that a lot of sensitive data doesn't come out of the large language model and being fed back to the user itself. So the input validation and the output validation is really, really critical when you're looking at a large language model, which is basically training based upon a large amount of data. So the first one is the prompt injection. The prompt injection is the one where we know that hackers can go in there and basically go in there and put some kind of a prompt into the system itself, into the large language model. And that's where they can either go and do a lot of cross-site scripting attacks, a lot of cross-site forgery attacks itself. And that's where we need to understand what kind of things that we can do, whether that be input validation to go and build upon a lot of these prompt injection attacks that can happen to the large language models itself. Now, another one itself is that we don't need to blindly trust the large language model. There could be a lot of excessive permission that is being given. We know a lot of these attacks happen, which is like, you go and put something into the large language model query itself, and you try to take out a lot of that data, even, when you don't have put the right controls, the right access controls into your large language model applications. And that's where a lot of that data can be leaked out. But also at the same time, when you are not using, for example, your principles of least privilege access itself, a lot of that data being relied upon, a lot of over-reliance upon the trusted user itself can be taken. And that's where also the concepts like least privilege and zero trust access are really, really critical when you're trying to build your large language model applications. The model theft is another one, right? Where we know that a lot of the companies which are leveraging a lot of the large language models, where their data itself can be at risk as well, where a lot of that data can be went and somebody can go and take out a lot of that data where you are building your applications itself. And that's another critical one where we need to take into account how we are deciphering the input validation into these large language model applications. Another one is the sensitive information disclosure, right? Where we know that a lot of these large language models, where they have been trained upon the sensitive information that's being put into the company's database itself, we don't want that data to be leaked out to the end user itself. And that's where we also need to be very critical as we are building these applications to make sure that a lot of that data doesn't come out of the system. Now, the next one is insecure output handling, which is the package hallucination, right? In this case, also, we have to understand that a lot of these large language models output itself, where we ask for something, but there are a lot of these hallucinations that happen, where there is an ability of these large language models to make up a lot of things itself. You ask for something, and if it doesn't have it, it just goes and makes a lot of these things by itself. And that's where a lot of these, we need to understand how do we only allow that particular application to give only the trusted data to the end user and not make a lot of these things by itself. Plugins is another one. As we are building a lot of these applications, we know that there will be a lot of these plugins, a lot of these agents that will be built upon these large language models. And we have to also understand that these plugins can also be a way for the hackers to come in and prompt into the system itself, into the large language models itself. And that's also something that we need to design these plugins to make sure that they are being secure as well. Now, this is another one, which is the model denial of service, right? Where if you don't have the right access controls, we are not rate limiting a lot of our large language models, where there is an ability for the end user to basically go and access a lot of these applications, but we don't have the right access controls in the backend, where a lot of the DDoS attacks can happen as well. And that's another thing that we need to take into control and into the consideration when we are building these large language models and adopting a lot of these applications into our systems at the backend. The next one is the training data poisoning. Now, we have talked about a lot of these controls from the point of view in terms of a lot of the data that gets leaked out. But then we also have to understand this as well, that a lot of the data that we are supposedly giving is also being trained upon with the large language model. And that's where we also need to understand that if we go and put that data back into the application, it has the ability to relearn a lot of the systems and a lot of the controls in the backend. So there is an ability, for example, for us to take that data and poison the system itself. So there is an ability. So we need to understand the entire supply chain of that software vulnerability itself, on how that large language model application can basically take a lot of that data, whoever feeds it, and relearns that and basically have an ability to poison your entire backend application itself. So a lot of these controls or the things that we have seen are from the point of view itself, where the ability for generative AI, that how we build these applications at large or at scale, have the ability that we can basically have to make that. But also at the same time, we need to understand it's not just dark and dreary, right? At the same time, there is an ability for us to look at a lot of these generative AI applications from the defense standpoint. How we can go and adopt these applications, and we can shift our perspective into building this as more of a defensive tool itself. Now, think of this as the things for example, your threat detection and prediction. Things, for example, when we are leveraging a lot of these tools for automated incident response, when we are trying to build a lot of these applications from the standpoint of vulnerability assessment and patch prioritization itself. There are a lot of these also at the same time when we are building these generative AI applications, adopting a lot of these generative AI applications to build upon things like UABA, which is user and entity behavior analytics control itself. So a lot of these, are built to build the real-time threat that identification and response as well. So let's start with the first one, right, which is your AI-enhanced threat detection systems that we are leveraging. So think of this as the first one, which is leveraging a lot of these controls for machine learning techniques in the threat detection itself. There is an ability for us to use, for example, like taking these controls of generative AI and leveraging it for the anomaly detection algorithms itself. But at the same time, we know that a lot of these, AI applications are so smart that they can also take, a large set of data sets and build upon the log analysis itself. So we can also leverage a lot of these threat detection systems of AI NS to also, make sure that we can also do a lot of these log analysis itself. Now, AI systems are also great to also detect a lot of the pattern recognition itself. So it's really important that we can also leverage, deep learning to understand a lot of the attacks that come from different geographies or different locations, and build a pattern recognition system itself to detect a lot of these threats, attacks that can happen. Now, when you look at a lot of these applications from the real world perspective, a lot of this happens because we can take a lot of this traffic analysis, whether that be on the network side or on the application side, to identify a lot of the unusual traffic flows that happen as well. Now, in the case of email filtering, a lot of these threat detection systems can also come in really, really handy, because we can use these for email filtering. We can use it for advanced phishing and malware detection, for example. We can also use it also at the same time for endpoint protection, where we can use it for either behavior-based malware identification, where we can go and test out a lot of these endpoint agents and understand the anomaly that are happening at every single endpoint level as well, just because of the level of sheer data that generative AI can go and decipher it out. Now, when you take a look at a lot of these AI-based applications, we need to understand that a lot of the incident response capabilities can be automated as well, just by leveraging a lot of the response workflows. So whether that be you leveraging, for the threat detection and triage, or whether that we are leveraging for the impact assessment as well, a lot of the remediation steps can be guided itself. Now, many of these steps, when we look at from the incident response, there are huge benefits to that. We can reduce a lot of our response times. We can also make sure that this gives us that inconsistency, the consistency in incident handling, how we are handling the back-end incidents from the SOC operational standpoint itself. AI is great at leveraging a lot of this tooling, which humans cannot decipher the trillions and trillions of data that we can't decipher. So in that case, that's really a critical understanding of having that ability for AI to decipher that and help us in the incident response as well. Now, when you look at the AI-driven threats overall and take a look at a lot of the proactive identification of this, majorly we look at from the three standpoint itself. It's majorly for the AI-powered threat intelligence. Then it's also for the behavior analysis and anomaly detection, and also for a lot of the security measures as well. Now, from the AI-powered threat intelligence standpoint, it's the ability for gathering a lot of that data for predictive analytics, for emerging threats itself, or also, understanding a lot of that monitoring that happens from the dark web or analysis that it can do based upon a lot of that data. Then at the same time, from the behavior or user behavior standpoint, we can take a look at a lot of this AI anomalies from the user behavior profiling that it can do, or also at the same time can go and decipher a lot of that data to do a lot of the pattern analysis and usage monitoring. On the predictive security side itself, a lot of these AI models can help us in the attack vectors, or also help us in the patch management or security policy adjustments to do a lot of the dynamic security policies that it can build upon. Now, we know a lot of the attacks that also now have started happening is through the AI-powered, whether that be a lot of botnet attacks. So we also need to understand that how we can build upon the strategies for whether that be on the phishing side or either from the email content analysis side. We need to take a look at things like, real-time URL and attachment scanning. Can we build upon a system where we can take a look at a lot of these emails that come through our system itself, and whether we can use AI-based tooling to go and detect that. We can also look at a lot of the sandboxing and detonation chambers, in terms of doing a lot of the automated threat hunting. And at the same time, we can also look at a lot of the third-party integrations where we can also understand that leveraging the AI-based tooling to do a lot of continuous monitoring of a lot of the third-party, integrations that we have already done into our systems itself. And the bigger one is in the supply chain side, where we can also take a look at the entire supply chain, software that we are, having, where we can do a lot of the enhanced vendor risk assessment and leveraging a lot of the mitigate a lot of the supply chain risk that we do have into our systems. So from the standpoint of the best practices from the AI security standpoint, it's really the biggest one that comes is, understanding and building the governance frameworks, building the clear policies on how we are adopting a lot of the AI use within the enterprises itself, how you're taking a lot of these controls. It's really important also at the same time to do a regular auditing and testing of these AI systems. Another one itself is that we have to understand that a lot of these AI-based tooling can also be very, very important, where we need to maintain the human oversight and accountability, for example, in that case. And ultimately, it's continuous learning and adaptation strategies. We have to think about how we can go and leverage a lot of these AI-based tooling to, cross-functionally collaborate as well into the enterprises itself. So combining a lot of this, the opportunities and challenges all together itself, the major one that comes is like, how do we take a lot of that human expertise? Because there are certain things that humans are great at. In that case, we need to understand how we can take that human expertise and leverage it with the AI capabilities itself. AI as an enhancer and not a replacement for a lot of the human analysts that we do have. At the same time, we need to think about leveraging AI for their data processing and the strategic decision that needs to be built upon itself. How we can go and leverage into our SOC tooling, into our AI systems that we are building upon, how we can go and build that trust between the human operators and the systems. A lot of that also is because we can go and build that adaptive security posture based upon the AI insights. Collaborating with a lot of the industry, academia and the government itself. At the same time, we also need to understand like how we can go and make that continuous feedback loop between the AI systems and the human experts itself. So when we take a look at the entirety of the challenges and the opportunities itself, we take a look at a lot of these from the future perspective. From the future's perspective, what are the things that we can go and automatically start leveraging on the AI standpoint? A lot of the things, for example, the trends in the AI and cybersecurity, like quantum-resistant cryptography, or for example, using the AI-driven for a lot of building your autonomous security systems, where you can go and automate a lot of the backend processes that you do have. We can also go and start building a lot of the federated learning, for enhanced privacy models. How we can take, our systems and build upon, all the third-party integrations, for example, that we have done. Also, at the same time, there are multitude of things that we can leverage, AI itself into the systems, where whether that we are looking from the legal and regulatory standpoint, or whether that we are looking from the threat modeling and risk assessment itself. There is also a huge AI based tooling that can be built upon the cyber risk insurance itself, and understanding how you can better assess a lot of the risk quantification when you are giving cyber insurance policies out there to the enterprises itself. So there are definitely a lot of the AI based tooling and AI based the opportunities that you do have in the space itself, which we can start building upon a lot of these tools itself. So just a few key takeaways on this side. Definitely there is a lot of the work that AI is helping out, with the cyber attacks as well, and as well as at the same time on the defense side as well. It's really important and critical that how we look at a lot of these AI-driven threats. It's important to build upon the security governance and ethical use of building a lot of these policies itself. A balance between both the sides, whether that be leveraging the human capabilities or AI security capabilities, is critical. And importance of the continuous learning and adaptation, as we are leveraging a lot of these AI tools into our applications as we are building upon it. So that's all from my side. Happy to take any questions that anybody has.